Let's continue data representation, that is number systems. Today we'll learn how to convert a binary number to decimal number, decimal to binary, octal to decimal and decimal to octal, hexadecimal to decimal, decimal to hexadecimal, octal to hexadecimal and hexadecimal to octal. Okay, already we have seen in the previous lesson how to convert a given binary number to decimal and decimal to binary. See, if any number is given, if a decimal number is given, if you want to get into binary, or if a binary number is given, if you want to convert it into decimal, how to do that? See, if binary is represented using zeros and ones only, that is two different symbols. So base 2 is mentioned. Okay, clear? So here 10101 base 2 is there. How do we convert? So this is 1's place, 2's place, 4's place, 8's place, 16's place. So wherever 1 is there, if you take that, because anything multiplied by 0 is 0 only. So 0 is identity, additional identity, isn't it? 16 plus 4 plus 1. How much it is? 21. Clear? So this is just a recap of what we have learned in the previous lesson. Okay, now let's continue. 10101.01. Suppose the decimal value is also there. Okay, binary, after dot if something is there. Then how do we convert? So this is 2 to the power of minus 1. This is 2 to the power of minus 2. So 2 to the power of minus 2 is how much? 1 by 4. Okay? And 2 to the power of minus 1 is 1 by 2. And then this is 1's place, 2's place, 4's place, 8's place, 16's place. Okay, so 16 plus 4 plus 1 plus 1 by 4. How much it is? 21.25. Clear? Now let's see. One more example. 110011.011 base 2. So here this is 1's place, 2's place, 4's place, 8's place, 16's place, 32's place. So 32 plus 16 plus 2 plus 1 plus, this is 2 to the power of minus 1, that is 1 by 2, 2 to the power of minus 2, that is 1 by 4, 2 to the power of minus 3, that is 1 by 8. How much it is? 51.375. One more example. 10001.101 base 2. How much you got? Yeah. 1's place, 2's place, 4's place, 8's place, 16's place, 31's place. So only 32's place. 32 plus 2 plus 1 plus 1 by 2 plus 1 by 8. How much it is? 35.625. Is there any doubt here? Clear na? After dot, whatever number is there, from there towards right to the power of minus, negative power. See, base 2. So 2 to the power of minus 1, 2 to the power of minus 2, 2 to the power of minus 3. That is the place value. So if you add the place value, if you multiply place value and face value and add all these values together, value obtained is decimal. Let's continue with decimal to binary conversion. Just recap of what we have learned in the previous lesson. See, number and decimal to be divided by 2. Note down the remainder. Divide the quotient again by 2. Note down the remainder. Repeat the same process till quotient becomes 0. Binary number is the number obtained by taking in reverse, that is from down to top, all those reminders. Clear? So now you see, for example, if 6 is a number given, okay, if you are asked to convert it into decimal, this is in decimal, isn't it? So 6 to be converted into binary, 236. Clear? 236. So now what is the remainder? 0. Next, 3 is a quotient. So this number to be divided by 2. So 2 ones 2 and remainder is 1. Next, 2 zeros 0, remainder is 1. So now quotient became 0, isn't it? So we cannot further divide this 0. So we'll stop here and we note down the reminders in reverse order. So 1, 1, 0, 0. That is the value equivalent in binary for the number 12. Is clear? So 12 is the number given and 2 6 are 12. So remainder is 0. Let's continue. One more example from decimal to binary conversion. See, after dot, if a number is there, that to be multiplied by 2. Note down the number after dot in the result. Multiply that number by 2. Repeat same step till it is, if it is terminating, till you receive 0. If it is non-terminating, up to certain decimal places. Now let's see. 0.12 is a number in decimal to be converted into binary. So what are we supposed to do? We have to multiply by 2. So 2 multiplied by 0.12, how much? 0.24. So 0 you leave it off. Before dot whatever is there, you leave it like that. And after dot whatever is obtained, that you bring it to next level for further multiplication. Now 2 multiplied by 24, 0.24. How much it is? 0.48. Now 0.48 is multiplied by 2, 0.96. 0.96 is multiplied by 2, 1.92. You see, here only 0.92 to be considered for further multiplication. 1 you just keep it like that only. Okay, don't worry about it. Now 2 multiplied by 0.2, how much it is? 1.84. The same thing, only 84 to be considered for the next level. So 84 is multiplied by 2, you will get 1.68. Like that you proceed. Is it terminating? No. So we will stop after some 4-5 digits or whatever is mentioned in the question. See now, in before dot whatever round figure is there, that portion we have divided now and taken the reminders in reverse order, top to bottom to top. Now we have to take from top to bottom all these values before dot. So it will be written like, see, 0, okay, next 0, next 0, next 1, 1, 1, 1, 0. So this is the binary equivalent of 0.12. Is it clear? Any doubt here? Clear? So now let's proceed with the one more example. See, you can check your answers after conversion. See, 10.25 is the number. 10 is converted by dividing and 0.25 is converted by multiplying. And together the result will be written. You see, 10. 2 5s are 10. Remainder is 0. 2 2s 4. What is the remainder? 1. 2 1s are 2. What is the remainder? 0. 2 zeros. 0. Remainder is 1. So now you take down the number in from bottom to top in reverse. 1 0 1 0 base 2. Clear? Now after decimal 0.25 is there. So 2 multiplied by 0.25, how much? 0.50. So 0.50 multiplied by 2, how much? 1. 1 after 1, 0 has already arrived. That means it is terminating number. So you can stop here and take down the numbers that is before dot from top to bottom. So now what is this value? This you will have 0 1. 0.25 is 0 1. So that's 0 1 and then this number is before dot whatever the value is there. So 1010.01 is a decimal equivalent, binary equivalent for a decimal number 10.25. Is it clear? Now let's proceed with the octal number system. Octal to decimal conversion and decimal to octal conversion. See, number of symbols, how many are there in octal? As the name indicates, octal means 8 different symbols. So what are the 8 different symbols? 0, 1, 2, 3, 4, 5, 6, 7. Because 0 we started with, no? So it will be going up to 7 only. Okay, remember this. 128 cannot be octal number because 8 is there, na? So 8 means it is not a symbol in octal system. Okay? So now 127. So it is an octal number. If you want to find out the equivalent decimal number, similar way of conversion from binary to decimal. Here number of digits are 8, no. So place value will be 8 to the power of 0, 8 to the power of 1, 8 to the power of 2. Like that it will go on from rightmost to left. Okay, so now you see 7 multiplied by 8 to the power of 0 plus 2 multiplied by 8 to the power of 1 plus 1 multiplied by 8 to the power of 2 will give you decimal equivalent of that number. You see one more example, 25.25. So 2 multiplied by 8 to the power of 1, 5 multiplied by 8 to the power of 0, 2 multiplied by 8 to the power of minus 1, 5 multiplied by 8 to the power of minus 2. So this will give you decimal equivalent of an octal number. Is it not similar to binary to decimal? Yes, it is similar. So if you thoroughly know one number system and how to convert from that to decimal or decimal to that, it is easy for you to see 2525 base 8 will become 21.328125 base 10. And this one you can take it as a homework and cross check your answer whether you are getting the same answer or not. And you can take any number in octal and convert into decimal and decimal to octal also. See, when you are converting decimal to octal, it is similar to decimal to binary conversion. Any number given in decimal to be divided by into which number system we are converting. So to octal. So 8. 8 ones are 8, 4 is remainder here, so 45, 8 fives are 40. What is the remainder? 5. Next 8 ones are 8, so what is the remainder? 7. And then 8 zeros, so what is the remainder? 1. So now from bottom to top you have to take down those numbers which will give you. Similarly, hexadecimal number system. Here, as the name indicates, hexadecimal. So, 16 different symbols are there. 0 to 9. Already these symbols are over. So, we cannot reuse some different symbols we want. So, we will be using A, B, C, D, E, F. A value is 10. Value of B is 11. C is 12. D is 13. E is 14. F is 15. Clear? So A value is 10, B value is 11, C value 12, D value 13, E value 14, F value 15. See, for example, convert the following 127 base 16 to decimal. So this is as usual when you are converting any number system to decimal. So 16 to the power of 0. Now 2 multiplied by 16 to the power of 1, 1 multiplied by 16 square will give you decimal equivalent of 127, 127 base 16. Now, similarly, if dot is there, so from here 16 to the power of minus 1, 16 to the power of minus 2, like that you have to consider. Let's continue. See, convert phase FACE by 16. E means how much? 14. C means how much? 12. A means how much? 10. F is how much? 15. So substitute those values. 15 multiplied by 16 cube plus 10 multiplied by 16 square plus 12 multiplied by 16 plus 14. How much it is? 64,206. How to convert decimal to hexadecimal? See, if any number is given, suppose 12 is given. So 16 zeros how much? 0. What is the remainder? 12. 12 means what is the symbol? C. Okay. So when you convert that one, number in decimal to be divided by 16. Note down the remainder. Divide the quotient again by and divide by 16. Note down the remainder. Repeat steps 3 and 4 till quotient becomes 0. Hexadecimal value is the value obtained by noting down all those reminders from bottom to top. See, now take one more number, 128. 16 8 how much? 128. What is the remainder? 0. And then quotient is 80. So 1600, what is the remainder? 8. So 80 is the equivalent value of 128. Clear? Any doubt here? Suppose after dot any number is there. What are we supposed to do? Multiply by that decimal, that number system into which we are converting. So 16 multiplied by 0.5 will give you 9.0. So what is the value after dot 0? So we can terminate. It is terminating. We can stop here itself. So 0.9 and then this is 80. 80.9. Clear? So keep watching and subscribe for more lessons. Thank you. Have a good time.